Yeah,
something.
so what you want, the answer is a fast iterative feedback loop.
Mm-hmm.
And it's more about building and testing and trying stuff than analyzing things. I used to believe that the right approach was to measure twice and cut once. And what I've learned is if you're trying to innovate, you cut 3 times, test and measure. Cut 3 times, test 3 times. When you've got it working, then you do your measurement. And innovation and discovery is about being willing to fail fast and learning from failure. I have a motto that I tell the R&D team at Momentus all the time, which is all knobs to the right. And if you haven't broken something in the lab this week, you're not working fast and hard enough. And so the team will sometimes, I'll say, how'd it go in the lab? And they say, well, we burned out this component. I say, what happened? Well, we were testing it and, we kept turning up the power. And at this power level, we found it broke. And I say, that's how you do it. Test to failure, and test to failure fast. And so one of the things that we do at Momentus is this was something that most of the folks from Momentus just fully embrace Agile from day one. Momentus embraces diversity. We have people from all different technical backgrounds. And I told the team, hey, we're building an in-house machine shop so that we can turn parts in hours instead of days. They said, you're crazy. We just bend it out. It takes a few weeks to get the part back. No problem. But in our R&D efforts, we need parts. Our R&D team, makes dozens of parts in a month. We can't wait weeks for parts. That would be ridiculous. And then even for flight hardware, if you're like, we're machining the Vigoride bus, that bus right there is on our big multi-axis machine tool right now, being hogged out of a big chunk of aluminum. It's really cool to watch it,
Right.
You can kind of see in that picture the isogrid structure. It's nice to see how that gets machined out. And sure enough, when we were machining it, we broke it. Well, that's why you machine it in-house, because you get insight into the manufacturing process and you see what breaks and what doesn't break. And there's nothing like getting your hands dirty if you really want to succeed.
Right. Yeah, I love that institutional knowledge, right? You can't fake it. You can't really buy it. And once you got it, they can't take it away. So,
that's right. That's right.
That.
And then that institutional knowledge is embedded in the minds of your people. And so reward your people, let them know how important they are to you. And everyone talks about that. And you can walk into a company and see the difference. I think in the last 8 weeks, I've hired 40 engineers at Momentus personally. And it is one of the most exciting things for me is just walk into that engineering floor and just feel the intensity of people behind their workstations and up at whiteboards and then walk into the lab and you walk straight from the engineering floor into the lab and it's back and forth between those and you see the guys hunched over their lab benches cranking and burning microwave components and all kinds of other things. It's just thrilling. It's absolutely exciting.
Yeah, and I love the idea of just go ahead and break it and don't worry about, okay, this is going to cost us some money. As long as you can absorb it.
Often as CTO of Momentus, engineers will come to me and they say, hey, we need to buy some of these components, And I say, well, how many do you think you need? Well, we need, we need the EM model, and then we need, the brass board, and then we need the test unit and the flight unit. So, 4. And I'm like, you need to buy at least 6.
Yeah.
Probably 8. And I can't tell you how many times. Okay, it's just something like, I'll tell you, a story from the lab at Momentus. Do you know what 80-20 bar is?
I know what the 80-20 rule is.
Well, the 80-20 rule is used for this stuff called 80-20. It's these machined aluminum bars that are called 80-20 bars.
Okay.
And for 20% of the cost, you can do 80% of all the structures that you need in the lab. So, and I said, you guys, I want to see stuff made out of 80-20 here, okay? For laboratory work, we can quickly assemble structures and that sort of thing and see how they go. And some of the engineers were ordering 80-20, and they brought to me the order, and I looked at it and I said, I need you to order 4 times as much. And they looked at me like, you're crazy.
Hmm.
And they ordered 4 times as much. And then 2 weeks later, they came back and said, we're out. And I said, okay, this time I want you to order 6 months supply. Okay. That was 3 months ago. They're just about out again. And so the point is you've got to have inventory. And people say, well, we can get it overnight. But if you're iterating rapidly in the lab, overnight is too slow. So the spirit of innovation and discovery, it's rapid innovation is what gets you to success.
More engineers are not going to solve your problem. It's not a technical problem in that sense. It's a process problem. And the time to fix your processes was 20 months ago. And the second best time is today. This is Jason Kanigan, the president of Cold Star Technologies and the host of this podcast, the Cold Star Project, which is all about identifying and solving process problems for space companies, because that's what we do. And you can hear the entirety of this episode by following the link in the comment below.